This video is going to cover complex numbers and simplifying expressions with complex numbers. So first off, what is a complex number? A complex number consists of a real part and an imaginary part. And the imaginary part is identified with the variable I. So we have the real part A plus bi, which is our imaginary part. So we designate the variable I with that. So just to help us out with, especially with example 2, if I have I to the 0 power, that's going to equal 1. I to the first power is equal to I to the second power is -1. And then we have I to the third power, which is -1 times I, which would be a negative I. And then we repeat I to the fourth. That's going to get us back to 1. Because it would be -1 times -1. -1 times -1 is 1. So when you are solving example 2, and I'll just do an example 2 first. I to the 84th power. All I would have to do is take the exponent and divide that by 4, because every fourth number is going to equal 1. And then, so when I do the division, whatever my remainder is, I'm going to match it up with one of these 5 numbers I have here. So 84 divided by 4 is 21. So it goes in evenly, so I have a remainder of 0. So if it has a remainder of 0, I look at I to the 0 power, which is going to equal 1. So now let's look at example 1 here. I need to simplify the square root of a -500. So I can't find the square root of a negative number because there's nothing I can multiply by itself to get a negative number. So to solve this one, I need to break this apart. So this would be the square root of -1 times the square root of 5 times the square root of 100. Now the square root of -1, if you see right here, the square root of -1 is I, so I know I'm going to have an I here. The square root of 100 is a perfect square, so that is 10. And then all I have left is the square root of 5. So my answer would be 10I square root of 5. Example 3, when you're adding and subtracting with complex numbers, you're going to add and subtract the real parts and combine the imaginary parts. So if I stack these, I have 5 plus 8I, and I'm supposed to be adding a -2 and a -7I. And when I combine like terms, 5 minus 2 is 3. 8I minus 7I is a positive 1I. So my answer would be 3 plus I. In our last examples, working with complex numbers, here I'm going to be subtracting the complex numbers. So I'm going to stack them up again. So I have 18 minus 3I. And I got to subtract all of this. So I'm going to be subtracting 14. And if I'm subtracting a -8I, I'm really adding 8I. Combine 18 minus 14 is 4. 3I plus 8I is a positive 5I. Example 5, I'm going to be multiplying binomials that have imaginary numbers in here, so I'm going to be foiling this. So 2 times 4 is 8. 2 times -2I is a -4I. 3I times 4 is 12I. And 3I times -2I is a -6I squared. Now -6I squared really means -6 times -1, which will really make this a positive 6I. So let me just combine like terms what I have right now. So I have 8 plus 8I, and then I have a minus 6 times a -1, which really is going to make this a +6. And then I have an 8i, and I have a +8, which will make my final answer 14 plus 8i. In our final example, we're going to have to conjugate the denominator. So that means we do not want an imaginary number in the denominator of our fraction. So the conjugate would be multiplying it by 4 minus I, because that's going to get rid of our imaginary number in the denominator. But whatever I do in the denominator, I must do in the numerator. So I got to multiply the numerator by 4 minus I. So now I have a difference of 2 squares in the denominator, which will be 16 minus I squared, which will really mean 16 minus a -1, which will really make that 16 plus 1, which will make that 17. So my denominator is 17. In my numerator, I would just distribute the 5, and I would have 20 minus 5i. So my final answer would be 20 minus 5i divided by 17, or I'm going to put this up at the top, I could have 20 over 17 minus 5i over 17. This would probably be the better two answers because that would be an a plus bi format. So that is how you can use operations with complex numbers.